Assalamu alaikum everyone, welcome to another video about introduction to Python. In this video, we're going to talk about functions and especially docstrings and tests. We will see why do we need docstrings and how they're going to help or functions to be easily understandable by the other users. So without further ado, let's begin. So you may have realized that some functions are not easy to understand. I mean, by only looking at its name and the input parameters, you may not be able to understand what is going on in that function. You need some help. In this case, you're looking for kind of documentation, and in Python, the documentation of functions are called docstrings. And we can add it to even to our own functions docstrings, so other users can benefit from that docstring and they can easily understand what is going on with the function and how they can use the function. So how to add docstring to our function? To add a docstring to our function, immediately after the function definition and input parameters, or another word, after a colon, we can add our docstring. This red part in here is a string because it uses the three double quotations, and when we create the strings with the three double quotations or single quotations, it means that we want to wrap the new lines in the string as well. For example, if you want to create a string with only single quotation or double quotation, you cannot use enter. Okay, if you do so, you're going to get a syntax error. But the same can be done with triple, single, or double quotation like here, because it handles the new lines as well. So after the colon, we can start a string and we can pass in whatever we want. Okay, but to make it to organize it better, so others organizes in the way that the conventions says, there are some conventions like this one. In here, the structure is as follows. First or two lines about what the function is going to do, and here get power is a simple function that gets two inputs, and it returns the num to the power of the power variable. I can add variable, maybe it makes it it makes it easier to understand, as here number to the power of power. And at the beginning you can add simple some lines of code to explain what the function is going to do, and after that you can talk about the parameters. And here in this structure, the parameters are wrapped by two colons at the beginning and the end, as you can see, the first colon and the end of the colon. And it says, okay, we're talking about non-parameter, and you can add a definition or a sentence to explain what is this argument, input argument, or what is this parameter. As is here, it says the base number, and the power says the base number will be raised to the power of this input or power variable. Okay, and at the end you can say you can explain what the function is going to return, and it says the function is going to return the num to the power of the power variable, as it says here. So this explanation is going to be shown to those that they want to get help from the function, from this function. So how to get help? As you can see here, there are several ways we can access this documentation, and almost in any standard function, I can say any standard function has this part or has a documentation that explains how to use it. So if you don't understand what is going on with any function, the first thing that I recommend you to do is to use help function. The help function is a predefined function in Python, and you don't need to import or do anything, and you can simply use it. It's like the print function, and you pass in the name of your function and it returns the explanation. like this. For example, it says help on the function get power, which is in the module main. We're going to talk about modules in future videos, so let's not get into this topic right here. But the rest is exactly what we have defined here. Okay, for example, I want to add a period at the end, and I'm going to run it again. And as you can see, the dot that I just included to this documentation, and you can see it here as well. So the help function simply prints the documentation of your function. So it doesn't matter where is your function or whether the user can access to your function or not, because maybe you want to release, you have released a library and the users are using your library as a third-party library, and they don't really want to check the source code, but they don't even need it, because simply by using help they can access to your documentation and simply see what is going on with your with this function and how they can use it. And let me show you, for example, let me show you the help of the print function. And as you can see, the print function is a built-in module like the help itself. Built-in function like the help itself, and it says, okay, this is how you can use print, what is the separation, what is the end, what is the file. It explains them all here in this manner. And as you can see, there is no return, because print does not return anything, simply just prints whatever you pass it to the std out or to the console. So using help, you can access anything you want, and you can get the docstring of any function that has the docstring, like this one that we defined. There are other ways to show the docstring. The first one is using question mark. It works in Jupyter Notebook and other IDEs like Jupyter Notebook. And as you can see, it pops up this section at the beginning of your screen, and it says, okay, this is the signature or definition of your function. It says the name of it is get power, and it has two arguments, number and power. And here is a docstring. Exactly, it mentions which part is docstring, like this. And it has some other information, like, for example, this is where the file lies in your code. It is IP kernel in the local, and the type is function. You can use this way as well to access the docstring. And in any case, if you want to see the source code, you can use double question marks like this one, and it shows you the source code. Okay, simply it shows you the exact code. And as you can see, we can see the docstring and the source code as well. So using this three approaches, you can access to docstring, and with the last one you can access to docstring and the source code as well. Here is another way, which we will discuss when we talk about OOPs. This is a special method, and by accessing to this special method, you can see the docstring like this, because almost everything in Python is an object, and the method that is responsible for docstring is called underline underline doc underline underline, and using this you can get the docstring like this. But it is not recommended. It's better not to use this way and use the three approaches that we discussed. So this is all about docstring. So it is recommended to include docstring to any function that you implement. It doesn't matter whether your function is easy to use or it is complicated. Just add the docstring. It's going to help the other users and even yourself in the future to remember what is going on with your function. So let's talk about tests. So what is tests? When you're implementing your code, you may want to, or in this case your function, you may want to add some tests to your function to make sure that your functionality, your idea that you wanted to implement is exactly how you perceive it to be, okay? For example, this get power function, I want to make sure that the code that I have is correct, okay? It's working the way that I thought at the beginning. In this case, we can add some tests to make sure it works, and we can ship the tests for the users, okay? When we add it to Docstring, this test will be shown to the users when they use help or when they call help on the function. So it has two benefits. The first one is that we are going to make sure that our function is functioning properly the way that we intended to. And secondly, the users can see the test, and sometimes some users like myself, I personally easily understand how to use that function when I see some tests. And in that case, I say, oh, I should use it like this. Okay, I should pass the input arguments, for example, integer, or whether I pass it float, it works. So in that case, I really easily understand what is going on with that function, how I should use that function. So tests are awesome. It makes sure that the code is correct, and the other users can easily understand how to use the code. It's kind of add extra explanation to your Docstring. So in here, for example, get power function, I have two tests. To add a test, we need to use this three signs at the beginning, and we should pass in the function name or the parameters that we want to define and implement our test. Here, for example, I want to test the fact that 1 to the power of 10 is equal to 1 or not. And I want to test the fact 2 to the power of 3 is equal to 8 or not, okay? Definitely, I can do this. For example, get power, say, okay, what is the output? Okay, the output is 1. Okay, it's working correctly. But the fact is I'm going to remove it, okay? And when I remove it, if I make any changes here, any change to the function, I have to again implement what I removed and make sure that it's working correctly or not. But if I add my test to Docstring, each time I use the doc test, I'm sure that I'm going to check all the tests, and I don't need to, for example, have another file of tests and test them each time, because my tests are in the documentation and others can see it, others can benefit from them as well. Actually, tests are very broad, is a very broad section how we should implement the test, how the function should be implemented at the first place, what is the unit testing, and all of this. This is a very broad topic that I don't that I'm really scratching the surface in this video, and I'm just talking about how we can implement tests in Docstrings. Okay, there are several ways that you can implement tests, that they are maintainable, and they are able to make sure that our function works perfectly. I just simply say this type of just checking a function on a cell and just removing it is not a standard way, and it's better to if you want to test your function like this, so it's better to add it to your Docstring, and which you in that case you make sure that the test will be available there. If you make any change, you know that that the tests are there, and if your changes break the code, that those tests will fail and will alarm you that you made a mistake, or you introduced a new bug, so you should change them. Okay, let me remove this line, and let's see whether my function works correct or not. To validate or test in the Docstring, there is a library called doctest. Using it is very simple. You just import doctest. This is a print that you don't really need to have it. You're just gonna pass in doctest.test mode, And whether it be verbose or not, it's about true or false. If you set it to false, it's not going to print a lot of stuff and a lot of details for you. But if you set it to true, it's going to give you all the details. It's going to provide you with all the details about the test. So it's better to set it on true, because to set it to true, because we want to make sure if anything is wrong, how we can fix it. So it's better to set it to true, like this one. And in here, okay, it's testing. Oh, I didn't restart the kernel at the beginning. Okay, God, I interrupted it. Okay, let me restart it. Because I didn't restart the kernel, it's simply tested all the tests available in this notebook. But we don't want it to happen. Okay, here. As you can see, starting the test, this is the print function that we added, information that we added at the beginning. And it says, okay, starting the test, and it says try and get power 1 to 10, this one. And it says expecting 1. It means what the user expects, what the coder expects is 1, as indicated here. But what happens? It says, okay, you expected 1, but you got 1.0. You see how exact is this? It says, okay, you expected 1 as integer, but your code is returning 1 as float, not as integer. So this is a problem here. And in this part, it says, okay, I'm trying get power 2 to 3. You expected 8, and okay, it's exactly what you expected. And at the end says, okay, failed 1, attempted 2 tests, which one of them failed, as you can see here. So as you can see, tests are awesome. Even this small problem, like getting integer or getting a float, simply is shown here, and it says it seems you expected an integer, but the code that you have implemented returns a float. So there are two options: whether your expectation is wrong and you really should get 1.0, or your code is not working correctly, functioning correctly. So whether change the test or change the code. In this case, okay, I check out the code, and I want to make sure that whatever it returns is a float. So I'm going to change the test as is here. For example, I want to change it to 1.0, and I'm gonna run the test mode again, and as you can see, it says trying get power 1 to and 10, expecting 1.0, and it's okay. You got exactly what you were expecting. And the same thing happened here. We attempted to for 2 options, and both of them passed. Both tests passed, and we had 0 failures. So this is how we can add or tests to our code, which helps at the first helps ourselves to make sure that the code is correct, and secondly, it can help the other users. And one more thing, the test should be at the end of your Docker string. And for example, if I use help here for get power, you can see that the tests are shipped as well. We can see the tests here. The tests are included. And for example, consider just looking at this, you can see that no matter you pass an integer or pass a float, it returns a float. So if we want to make sure if you want to make sure your output is an integer, you should, for example, convert the output to integer or something like that. And this says return num to the power of power, which okay, I by reading this explanation and checking the outputs, I can understand okay what is going on. And in here you can add more extra information. We will talk about type hinting in the future video, if I'm not mistaken. But you can add it in your Docstring. In the previous code, they would do so. For example, they would say, okay, you get, we have two arguments. The first one is float, should be float. The second one should be int, and it will return a float, okay? It will kind of hint the third user, how the user, how the type of the inputs and outputs should be. Okay, let's see another example here. We've got another example like this one. For example, this is the definition, and this is another test. We passed in the argument, and this is what we expect. Let me run it, and as you can see, it says attempted 3 options, and the verbose is set to false. It says we tested 3 options, and we got 0 failures. So this function is perfect, no failures. It works correctly. So in this section, we want to talk about how to add failures to your code. There are some circumstances, there are some scenarios that your code will fail. I mean, it should fail. Like dividing an integer to 0, okay? Which returns a 0 division error, okay? There's no... In this cases, you want to kind of tell the user, if you, for example, if you use the code in this way with this kind of inputs, you're going to get an error, okay? The function will raise an error. So be cautious, don't use the function in this way, because if you do so, you're going to get an error. So how we can add this as a test to our Docstring? Definitely you can, for example, write it here. Explain it in plain English how that will happen. For example, you could write dividing whenever b is equal to 0, you're gonna get 0 division error. That's possible. But how we can add this failure as a test? So if you want to do so, we're gonna write the input like this: division 10 to 0, 10, and the other parameter is 0. And at the end of it, we should pass in exactly the error. For example, here, if you, for example, let me run this. This is the division function. Whenever I run it, it's 10 to 0. It says, okay, 0 division error. And here we should add the exact error at the end. And you should add the traceback most recent calls at the beginning. Okay, you don't need to add whatever comes at the beginning. You don't need to add the trace of the error in your Docstring to correctly work. You simply need to add the beginning and the exact end of the error here. For example, if I remove this one from okay, let me put on my charger. Okay, if I remove this one from the Docstring and run it again, as you can see, it says expect fail example division 10 to 0. It says expectation raised, this one, whole of it, but you didn't add it. You didn't expect it. For example, let me set verbose to true. Have the same. Okay, here it says trying division 10 to by 0, and whatever, this is what you expected, but this is what really happened, okay? But we don't need to add this part, because the Docstring understand, or the test understand, this section is depends on any user's computer. For example, here I'm running this code in on Windows, and it says, for example, C users Puya. Maybe your machine name is something else, or maybe you run it in a Linux machine, and it's here. It says, for example, slash home and blah blah blah. So definitely this can't be the same for different users, but this part and this part, these two parts are the same for any user. So if you want to add a failure to your docstring, you should make sure that you add this one at the beginning, the traceback, and the final error at the end. And simply, really, if somebody looks at, somebody get the help of your function, simply realizes that, okay, if I use this code in this manner, I'm gonna get division by 0. So definitely they're not gonna try it because they will get the error. So this is the error. This is how we can get the help as well. Again, you see that we have the documentation that says divides a by b, and this is an example of divide, which 10 divided by 2 is equal to 5, and 10 divided to 0 equals to 0 division error. Okay, this is another advanced division. That in this advanced division, I want to show the user different types of tests of the code, different ways that the code can be executed, and I want to make sure that I convey the message how to use this code. This is an advanced way of, for example, dividing, and in this one, I don't return I don't have a 0 division error. Whenever the A and B, for example, both of them are equal to 0, I return 1. Okay, I want to, for example, make sure that 0 divided by 0 is 1. And whenever B is 0, I want to just return infinite number. Okay. This is an advanced way. To make sure that the user really gets the point, I have added all different types of way that this code can be executed. The first one is the usual one, okay? As you can see, 10 divided by 2, which is equals to 5. And the other one is dividing 10 to 0, okay? This is different aspect of this, different aspect of how to use this function. 10 divided to 0, it says, okay, it's going to return an infinite number, okay? And if you divide the negative number to 0, it's going to return you a negative infinite number like this, negative inf. And if you divide 0 by 0, you'll get 1. So again, there is two benefits of adding different types of tests to your code. First of all, you're going to make sure that you're testing your code in any way that you can test it. So you make sure that there's no way that you haven't tested your code and your code is kind of covered in all aspects. So there wouldn't be any bugs. The first benefit of having all types of tests. And the second one, by doing so, the user will get how differently it can use your code. It can use your function. Okay, the user will understand. Okay, if he divides 0 by 0, he'll get 1. If they divide 0 by 0, they'll get 1. If they divide a negative number to 0, they'll get a negative inf, and the same applies for two other tests here. So the tests, let me run this one. And one more thing, when you use the doc test mode, it tests all the functions. Okay, it does not work just for one function. Test all the function available in your code as it is here, and it says attempt 9 tests, and 9 of them passed. 4 of them are here. 2 of them are here, which makes it 7. And one of them is here, which makes it 8. I don't know, maybe I'm making mistakes, but whenever it's no, yeah, exactly. 4 of them are here, and 2 of them are here, which makes it 6. 1 of them are here, which makes it 7, and 2 of them are here, which makes it 9. So we got 9 tests, and all of them passed. So as a final note, try to add as many tests as you can, and elaborate your code as much as you can, so others can benefit from your documentation. So till the next video, have a good time.